So the CH-53K is the state-of-the-art heavy lift helicopter for the entire Department of Defense. It has 20% more lift than our previous predecessor, the CH-53 Echo, and it can also lift much more weight than the Echo could.
This is USA's most expensive and brutal new helicopter, just unveiled by the U.S. Marine Corps, and it's unlike anything the world has ever seen. Towering above its predecessors, the CH-53K King Stallion combines sheer power, cutting-edge technology, and a jaw-dropping $131 million price tag. Our max gross weight when we're doing external lifts is 88,000 pounds, and we can lift loads up to 36,000 pounds, which is much easier to do in this aircraft than what the Echo was available. Designed to carry tanks, armored vehicles, and up to 37 fully equipped troops, it redefines what heavy lift means in modern warfare. From its 3 massive turboshaft engines to advanced flight controls and armor, every inch screams dominance. But what makes this beast truly brutal? And why did it cost more than any other helicopter in American history? The answer lies deep in its engineering. The giant awakens. The desert sun glinted off the massive rotors of the CH-53K King Stallion as it rested on the tarmac. A metallic giant that seemed almost alive. Its 7 composite blades stretched outward like the wings of a predatory bird. Around it, Marines and engineers moved with a mixture of reverence and apprehension, their eyes tracing every curve, every panel, every rivet. This was not merely a helicopter. It was a flying fortress, a mobile engine of war built to rewrite the rules of heavy lift aviation. "You won't believe what this machine can lift," muttered Major Daniels, a veteran Marine whose face had seen decades of operations in deserts, jungles, and mountains. He watched the rotors begin their slow, mesmerizing spin, the vibration humming through the tarmac like the heartbeat of a sleeping giant. Designed to lift up to 36,000 pounds externally, the King Stallion could hoist 2 fully armored HMMWVs in a single sortie, vehicles that would normally require an entire transport plane or a convoy of smaller helicopters to move. Inside, the cabin was just as formidable. 2 10,000-pound AMC 463L pallets fit comfortably within its widened fuselage, which had been expanded by 12 in over its predecessor. Every detail screamed engineering precision. Reinforced floors, tie-down rails, corrosion-resistant panels, and modular seating that could be rearranged to accommodate troops, vehicles, or medical evacuation gear. The composite fuselage designed to resist the harshest environments, salt spray, sandstorms, and enemy fire, combined with energy-absorbing landing gear, meant that the King Stallion could survive conditions that would ground almost any other aircraft. The 3 G408 engines, each producing 7,500 shaft horsepower, thrummed quietly now, but promised a power output unmatched in U.S. military aviation. The split-torque gearbox translated this raw energy into effortless controlled lift, while the fly-by-wire controls allowed pilots to manage the helicopter's immense strength with the lightest touch, as if piloting a feather rather than a behemoth. Every system, from the integrated vehicle health monitoring system to redundant electronics, was designed to anticipate failure before it happened, ensuring that the King Stallion could operate in the deadliest, most remote theaters without faltering. And yet, all this capability comes at a price. $131 million per unit, including research, development, and support infrastructure, making the CH-53K the most expensive helicopter in U.S. history. Critics balk at the figure, but when a helicopter can haul tanks from ship to shore, ferry troops across a burning desert, and operate in conditions that would destroy anything else, the cost begins to make sense. Some people don't understand until they see it lift a 36,000-pound payload while barely trembling, Daniel said. Then they get it. Every penny counts when lives and missions are on the line. As the rotors picked up speed, the ground itself seemed to hum beneath the King Stallion. The Marines braced, not out of fear, but in awe of what they were about to witness. For here was the future of heavy lift. Aviation, a machine so meticulously engineered that it could redefine how war is fought. But with all this raw power, precision, and technological marvel, one question lingered in the desert air. How does an aircraft like this perform in the heat of real combat when every system, every rotor, and every engine is pushed to its absolute limit? Power that defies gravity. 3 Get 408 turboshaft engines thundered to life. By comparison, the CH-53E, its venerable predecessor, struggled with 3 T-64 engines delivering far less power. The King Stallion packs nearly 57% more raw thrust, transforming it from a workhorse into a leviathan of the sky. Engineers designed these engines to endure the harshest conditions imaginable. Sandstorms whipping across desert battlegrounds, saltwater corrosion from amphibious operations, and the punishing humidity of tropical coasts. Not a single turbine blade falters, even under extreme duress. It's not just power, Lieutenant Commander Hughes said, running his hand along the rotor hub with a reverence usually reserved for ancient weaponry. It's reliability. You could lift a tank in the middle of a desert, and this baby won't even flinch. That raw energy is channeled through a massive split-torque gearbox into 7 composite rotor blades. Each blade, with its swept and hedral tips, slices through the air with surgical precision, minimizing drag while maximizing lift. Lightweight, yet unbelievably strong, they are the culmination of decades of material science. The elastoic rotor hub eliminates traditional metal joints, slashing maintenance needs, and drastically reducing the risk of in-flight failures. And yet, despite this immense brute force, the King Stallion cruises comfortably at 170 knots, a speed unmatched by most other heavy-lift helicopters. But with this much power, how do pilots keep the helicopter from turning into an uncontrollable beast in the sky? Fly-by-wire mastery. The answer lies inside the cockpit, where a sweeping digital glass panel replaces the old clutter of dials, gauges, and levers. Fly-by-wire technology translates the tiniest pilot inputs into precise rotor movements, making maneuvering a massive payload feel deceptively effortless. Captain Reynolds manipulated the controls with the calm of a seasoned conductor, a grin spreading across his face. "Feels like you're moving a feather," he said. "Except that feather can carry thousands of pounds and fly across a desert canyon." Watching silently, the Integrated Vehicle Health Monitoring System, IVHMS, tracked every heartbeat of the machine from engine output to rotor stress, hydraulic pressure, and temperature fluctuations. Predictive maintenance algorithms alert crews to potential failures before they occur, cutting downtime and keeping the helicopter mission-ready at all times. The King Stallion isn't just brute force. It's intelligence in the sky thinking ahead, safeguarding itself and its crew. But even the smartest system faces Mother Nature's fury. How can a machine this complex survive punishing conditions like rolling seas, saltwater corrosion, and high-altitude heat that would ground lesser helicopters? Fortress in the sky. The CH-53K isn't just a flying truck. It's a mobile fortress. Over 75% of its fuselage surface is composite, delivering astonishing structural strength without excess weight. Energy absorbing landing gear ensures that even catastrophic touchdowns don't the airframe. Corrosion-resistant coatings and foldable rotors allow the King Stallion to dock safely on naval vessels, ready for amphibious assaults or storm-lashed missions at a moment's notice. It's like a Swiss Army knife on steroids, Sergeant Lewis joked, eyes glinting as he gestured toward the massive cabin. It can drop troops, haul vehicles, and still survive if a storm hits out of nowhere. The cabin itself has been widened by a full foot over the CH-53E, allowing for bulkier payloads. Combined with a gross weight of 88,000 pounds, it is optimized for expeditionary operations. Lifting tanks, carrying troops, or delivering supplies directly from ship to shore in the most hostile of environments. Every element, from fuselage materials to rotor dynamics, was designed for one mission: uncompromising performance under pressure. Yet, even with cutting-edge materials and systems, no helicopter is invincible. Mechanical failure can still spell disaster. So, what measures did engineers implement to ensure the King Stallion survives when the stakes are life and death? Resilient and ready on the tarmac, the CH-53K sits like a mechanical beast, rotors still, yet humming with potential energy. Its real power isn't just in brute strength, it's in foresight. Predictive maintenance is the lifeblood of this machine. The Integrated Vehicle Health Monitoring System, IVHMS, continuously collects torrents of data from every corner of the helicopter. Engine vibrations, rotor stress, hydraulic pressures, temperature fluctuations, even microscopic cracks forming in the composite fuselage. This information flows seamlessly to onboard systems and ground teams, allowing technicians to anticipate wear and tear before it becomes mission-critical. The split-torque gearbox, capable of channeling nearly 22,500 horsepower from 3 engines to the rotor system, has been engineered to endure extreme stresses without faltering. Composite rotor blades resist erosion from sandstorms and sea spray, while the T408 engines with fewer moving parts than their predecessors minimize points of catastrophic failure. Every line of code in the IVHMS, every weld, every bolt, has been designed with a single objective: survivability. Every component from the rotors to the electronics has a backup or failsafe, said Dr. Simmons, one of the lead engineers behind the program. We designed this helicopter to survive situations that would destroy anything else. Even with such foresight, all this technology comes at a staggering cost. And the question isn't just how much, it's why. Price of power. The CH-53K King Stallion isn't just the most powerful helicopter ever developed for the U.S. military. It's also the most expensive. The total program acquisition cost hovers around $27.7 billion, a figure that includes research, development, testing, production setup, and support infrastructure. Each unit carries a jaw-dropping price tag of $131 million, though the flyaway cost of the helicopter itself initially started at $87 million before production refinements pushed later units closer to $97 million. Several factors combined to drive this astronomical price. First, there is advanced technology. Composite rotor blades, fly-by-wire controls, and the IVHMS collectively push the boundaries of modern aviation. The 3 high-powered T408 engines provide enough lift to carry tanks, trucks, or entire platoon in one sortie, while survivability features like energy-absorbing landing gear protect both crew and cargo in the event of a hard landing. Shipboard and marine compatibility adds further complexity, demanding corrosion-resistant materials, folding rotors, and reinforced landing systems for operations at sea. Non-recurring engineering costs, the one-time expenses for tooling, initial production line setup, and exhaustive testing also inflate the price. These are the hidden costs that most casual observers never consider, but are essential for ensuring that each helicopter meets the uncompromising standards of the U.S. Marine Corps. Some people balk at the price, admitted Major Daniels, arms crossed as he watched a King Stallion lift off the deck. But when you're lifting tanks from ship to shore in the middle of a desert under fire, it's worth every penny. And yet, with such a colossal investment, the question remains, can the King Stallion deliver in ways that justify its price? Is it merely a marvel of engineering or a true game-changer on the battlefield? Battle-tested in concept. Before the CH-53K ever lifted off a runway with Marines or cargo, it was put through grueling trials in simulators and controlled test environments. Engineers created sprawling mock deserts complete with sandstorms, jagged terrain, and heat radiating off tarmac alongside rough sea simulations to mimic the tossing decks of amphibious assault ships. Every conceivable scenario, from vertical extractions under enemy fire to high-altitude cargo lifts, was tested repeatedly. Each iteration pushing the helicopter to the limits of engineering. Pilots practiced amphibious extractions, loading and unloading troops and vehicles in rapid succession, while systems engineers monitored every vibration, torque reading, and rotor flex. Each successful maneuver confirmed one undeniable truth. The King Stallion wasn't just a helicopter. It was a revolutionary tool for modern warfare. One particularly intense demonstration left even seasoned Marines wide-eyed. A CH-53K lifted not one but two fully armored HMMWVs in extreme heat and high-altitude conditions, a feat that would have grounded nearly every other heavy-lift helicopter in the U.S. inventory. "It's like the difference between a sports car and a freight train," said Captain Reynolds, wiping sweat from his brow after the lift. "The power is unbelievable, but it's controlled, precise, and reliable. You can feel the helicopter thinking ahead for you." Even with this raw power, pilots reported a surprising sense of finesse. Tiny fly-by-wire inputs allowed for surgical precision when maneuvering in confined spaces, while the wide cabin and reinforced landing gear offered both flexibility and safety. Every test reinforced the idea that the CH-53K could perform missions that were previously unimaginable, standing above the rest. So how does this new behemoth compare to the rest of the world's heavy-lift helicopters? The answer is simple. Nothing comes close. Within the U.S. inventory, the CH-53K eclipses its predecessor, the CH-53E Super Stallion, by nearly 50% in lift capacity. Globally, only the Russian Mi-26 can approach the sheer tonnage it moves. But even then, the Mi-26 is an older design, lacking modern avionics, fly-by-wire controls, and predictive maintenance systems that allow the CH-53K to operate reliably in unforgiving environments. European heavy-lift helicopters, like the Airbus H225M Caracal or the Sikorsky S-92, cannot match the King Stallion in combined payload range or versatility, particularly in amphibious or high-altitude desert operations. When we finally needed a heavy-lift helicopter that could do everything, carry vehicles, troops, supplies, and do it anywhere, in any condition, this was the answer, explained Lieutenant Commander Hughes, arms crossed as the rotors of a CH-53K hummed in the background. Nothing else even comes close. From lifting tanks to deploying special operations teams from amphibious ships to mountainous terrain, the King Stallion transforms how the Marine Corps projects power. Its capabilities extend the reach of the U.S. military, giving commanders options that were previously impossible. And yet, despite outperforming every helicopter on the planet, the question lingers. Why did development drag on for decades? And why did costs soar into the tens of billions? Titans before the Stallion, a legacy of lift. Long before the CH-53K King Stallion dominated the skies with its awe-inspiring strength, the world of heavy-lift helicopters was already a story of ambition, innovation, and escalating costs. The helicopter, once a fragile experimental aircraft, has evolved over nearly a century into a battlefield powerhouse, each generation surpassing the last in power, payload, and technological sophistication. The roots trace back to the 1940s and 1950s when early heavy-lift workhorses like the Sikorsky H-119 Chassis and the CH-37 Mojave first demonstrated the military potential of rotary wing flight. These hulking machines were capable of carrying soldiers, supplies, and light vehicles, but they were slow, fuel-hungry, and mechanically temperamental. A single mission often required careful calculation. Too much weight, and the aircraft would struggle to take off, too little, and the operation was inefficient. By the 1960s, the CH-53K Stallion emerged as a true game-changer for the U.S. Marine Corps. Its three T-64 engines delivered unprecedented lift, and its internal cabin allowed for troop transport and vehicle carriage in a single flight. It wasn't cheap. Costs per helicopter in that era approached $3 to $4 million, or roughly $25 to $30 million in today's dollars, adjusted for inflation. But its capabilities justified the expense. Every pound lifted and every soldier delivered safely mattered in a world defined by conflict in jungles, deserts, and urban battlegrounds. The CH-53K Super Stallion, introduced in the 1980s, pushed the envelope further. With three T-64G 416A engines producing 4,380 shaft horsepower each, the CH-53K could carry 27,000 pounds externally, roughly a 50% increase over the original C Stallion. This helicopter required immense engineering ingenuity, a split-torque main gearbox, wider rotors, and strengthened landing gear, all contributed to its remarkable performance. But the price reflected its ambition. Unit costs reached $18 million to $20 million at the time, and when factoring in research, development, and early production, the program ballooned into billions. Soldiers and planners understood the logic. Heavier lift meant fewer sorties, fewer helicopters exposed, and more strategic flexibility. Across the globe, other nations were trying to compete. The Soviet Mi-26 Halo, still the largest and most powerful helicopter in production, could lift up to 44,000 pounds. But it came with limitations: older avionics, analog controls, and less reliable predictive maintenance. Europe produced the NH-90 and CH-47 Chinook derivatives, capable yet unable to match the lift, speed, or survivability of the U.S. heavy lift machines. Costs climbed in parallel with capability, creating a consistent pattern. Power is expensive, and history has shown that militaries are willing to pay. The story of heavy lift helicopters is really the story of trying to do more with less risk, explained Lieutenant Commander Hughes, watching a CH-53K engine warm up. Every generation tried to lift bigger loads, fly farther, and survive harder conditions. And every generation got more expensive because building something that can do all that isn't cheap. By the time the CH-53K program began in the early 2000s, the stakes had changed. No longer was it enough to lift vehicles. The military demanded speed, survivability, advanced electronics, predictive maintenance, and marine compatibility. Each of these features compounded cost, culminating in a unit price that dwarfed all previous helicopters. $131 million per aircraft, with total program costs exceeding $27 billion. But in context, the King Stallion is the natural heir of a line of heavy lift titans, each iteration reflecting decades of technological evolution and battlefield experience. From the earliest Chickasaw to the massive Super Stallions, one lesson is clear. When it comes to moving the heaviest loads under the most extreme conditions, cost is measured not just in dollars, but in capability and survivability. Every increase in lift, every improvement in materials, every engine upgrade has been paid for over decades in the currency of engineering ambition and human lives saved. And yet, even with this legacy of triumph and innovation, one question looms over the CH-53K. Can the most expensive helicopter in history justify its staggering price tag on today's modern battlefield? where threats are faster, smarter, and more lethal than ever before. And why did it take so long to achieve? Years in the making, the CH-53K program officially took flight in the early 2000s, but its roots stretch back decades through a labyrinth of research, experimentation, and engineering breakthroughs. Materials science labs had been testing new composite alloys for rotor blades that could be both lighter and stronger than any previous designs. Engineers experimented with elasto-rotor hubs that eliminated traditional metal joints, drastically reducing wear while increasing reliability. Meanwhile, turbine specialists were pushing the limits of the GET-408 engines, ensuring that each could produce 7,500 shaft horsepower while resisting the abrasive sands of deserts, the corrosive salt of oceans, and the punishing heat of high-altitude operations. Avionics teams worked tirelessly on fly-by-wire systems, integrated health monitoring, and cockpit displays that translated complex machinery into intuitive pilot inputs. "We wanted more than a helicopter," said Dr. Simmons, lead systems engineer. "We wanted a strategic tool, one that could go anywhere, lift anything, and survive anything. It's not just air mobility, it's battlefield dominance." Years of simulations, prototypes, and redesigns were necessary to meet these goals. Each failure, blades cracked, gearboxes overheated, software lagged, was meticulously studied and corrected. Every adjustment added time, manpower, and cost. And, collectively, they drove the program's price tag into billions of dollars. Yet, the payoff is a machine unmatched in modern aviation. A flying fortress capable of lifting entire armored vehicles, a technological marvel where raw power meets precision control, and a heavy lift beast engineered to survive the most hostile environments. But it begged the question ultimately of what this meant for the future. A glimpse into the future. With its unprecedented combination of power, reliability, and technological sophistication, the CH-53K isn't just a replacement for older helicopters. It's a game-changer for U.S. military aviation. Commanders now have a tool that can lift more, fly further, and survive longer than any other helicopter in history. From rapid response troop deployments to moving critical supplies in high-risk theaters, the King Stallion extends the reach and flexibility of the Marine Corps like never before. And yet, as the rotors slice through the sky and the sun glints off its composite fuselage, one question remains, lingering in the minds of pilots and engineers alike. How will this extraordinary machine redefine warfare? And what missions will it enable that were once unimaginable? The CH-53K King Stallion, the U.S. Marine Corps, has ushered in an entirely new era of heavy lift capability. Unlike its predecessors, this helicopter is no longer simply a transport tool. It is a strategic instrument of battlefield dominance. Survivability is built into every inch of the aircraft. The fuselage, composed of over 75% advanced composites, resists corrosion, extreme temperatures, and ballistic threats. Energy-absorbing landing gear ensures that even in rough or improvised landing zones, both crew and cargo emerge unscathed. Fly-by-wire controls, guided by the sophisticated Integrated Vehicle Health Monitoring System, IVHMS, allow pilots to operate this 88,000-pound behemoth with the precision of a sports car, translating raw horsepower into controlled, devastating efficiency. Beyond raw lifting power, the CH-53K changes the calculus of modern warfare. Commanders can now move men and machines faster than any adversary can react, creating tactical flexibility that rivals even the most advanced armored units. Whether executing amphibious assaults, high-altitude desert insertions, or long-range logistical support, the King Stallion blends speed, muscle, and intelligence in a way no previous helicopter could. On the flight deck, as the rotors finally slow and the helicopter settles with a controlled thump, the silence that follows is almost reverent. Engineers check readings, pilots run post-flight protocols, and Marines stand in awe. Hundreds of thousands of moving parts, billions of dollars in research and development, and decades of engineering have converged in one machine, a flying fortress that can lift tanks, ferry troops, and dominate the battlefield with a quiet, terrifying grace. "It's more than a helicopter," says Lieutenant Commander Hughes, wiping sweat from his brow. "It's the embodiment of mobility, firepower, and survivability. One aircraft, but it changes everything." Yet, as impressive as the King Stallion is today, its introduction raises a critical question. What does this mean for the future of U.S. military aviation? And how will adversaries adapt to a helicopter that can do what was once unimaginable? What do you think? What would you expect from such an expensive machine? Let us know what you think in the comments below. Thanks for watching. Until next time.